So now that we have both of those, we can go back to our deploy script and finally start looking into deployment. So we're going to say, we're going to first import that helper config from slash helper config.s.sol like this. Now in here, we're going to deploy a new helper config. So we're going to say helper config equals new helper config. And now based off the active network config, we're going to get all this stuff. So I'm actually just going to copy all this here, all this whole struct, paste it in here, remove the semicolons, replace them with commas, except for the last one. And I'm going to say all of those equal helper config dot active network config, right? So this line here is equivalent to if I imported network config from the helper config, I did network config equals this, but I'm deconstructing this network config object into the underlying parameters. So this is deconstructing that, and that's how I can just get all the individual pieces like this. Cool. So now that we have all those, what we can do is we can actually do our vm.start broadcast, and then we'll do a vm.stop broadcast like this, and we'll say raffle equals new raffle. I'll put on all these parameters in here. Raffle.sol. Are these in order? It looks like these are in order, so I can just do them in order here. Entrance fee, interval, VRF, coordinator, gas lane, subscription ID, and callback gas limit. Cool. And then we can do return raffle. Now, at a high level, this should be good enough, but we're actually going to make this deploy script even more robust. There's a couple things that we need here. Number one, we need a subscription ID. We need to get that either from the UI or we need to make it ourselves. Because I'm a dev, I want to have my script do everything for me. But if you want, we could 100% just get that subscription ID from the UI. So we're going to need to refactor this, but let's pretend for now that this is good. So let's just pretend this is good, even though we know this isn't good. Let's go ahead and start writing our tests, right? So cool. We've got a deploy script. We've got our helper config. Great. Let's go ahead. Let's write our first test. So in here, we're going to make two different folders. We're going to do unit tests. We're also going to make another folder called integration tests. As always, we're going to start with our unit tests. We're going to create a new file, raffletest.t.sol. So you know the drill, spdx, license identifier MIT, pragma, solidity, 0.8.18, contract, raffle test, like this. I spelled solidity wrong. That's better. And we're going to need to import some stuff. So we're going to need to import that deploy raffle, first of all, from /script/deploy raffle.s.sol. We're going to need to import raffle, of course, from src/raffle.sol. We're going to need to import test and console, if we want to use that, from forge std test.sol. And we're probably going to need to import some more stuff, but let's just start from here. So we're going to say raffle test is test. And let's go ahead and create some stuff. So first we're going to need function setup. It's going to be external. And we're going to create our raffle deployer. So deploy raffle deployer equals new deploy raffle. And we're going to do raffle equals deployer.run, right? Because our deploy raffle is returning our raffle here. So that's how we're going to get a raffle. And we should actually save this up top. So we're going to say raffle, and do this so they don't shadow each other. And we should create some starting user to interact with our raffle here. So we're going to say address public player equals make ADR player. And this is one of the standard cheats that we're going to be using, right? This make ADR. And we're probably going to want to give them a starting balance. So we'll say uint256 public constant starting user balance equals 10 ether. Now, a good point that I want to point out here is that in my tests, I'm a little bit more lax with the layouts and the conventions. I think they're more important for your actual contracts here, the layouts and conventions and everything, just because this is the actual code that's being tested. I still think it's good to do them in your tests and everything, but you'll notice I'm a little bit more lax. Now, additionally, with all this, we probably also want to be testing our deployments. So we also probably want to get all of our stuff from the helper config, right? So we can do import helper config from /script/helper config.s.sol. And right now, our deployer.run is only returning the raffle, but it's probably a good idea to return both the raffle and the helper config. That way our tests can have access to the exact same variables that our deploy had access to. So at the bottom, we can say return raffle, comma, helper config. Now in our tests, we can say, we can add a new helper config like this. And we can say raffle, comma, helper config equals deployer.run like that. And then we can get all the variables by doing by doing exactly what we do here. So I'm actually just going to copy this line in the deploy raffle, paste it in here, but I'm going to copy all these, make these state variables. I'm going to turn all these commas into semicolons. There's a much faster way to do this, but I'm just going to do it like this for now. And then remove the types here. Cool. So now all of these are getting saved up as state variables, and I can use them in my test below. Cool. So let's even do a quick sanity check. So we'll say function test raffle initializes in open state. We'll make this a public view of a test, and we'll just say assert raffle.get raffle state. Do we have a get raffle state function? Oh, we don't. So we should make a get raffle state because we have our raffle state private here. So I'm actually going to copy raffle state, scroll to the bottom, do function get raffle state, external view returns raffle state, return s raffle state. Now we have this get raffle state function. So we'll say raffle.get raffle state equals, and this is where we do a little bit of weird stuff that you probably haven't seen before. We can get that raffle state enum by saying raffle state dot open. Since raffle state is a type, open. Oops. Since raffle state is a type, what this part is saying, hey, on any raffle contract, that raffle state enum or type, get the open value for that. So it should initialize in the open state. So let's go ahead and test this out. We'll say forge test, since this is the only test we have in here. We're going to go ahead and compile everything, get a whole bunch of issues with the libraries, which we're not really going to bother fixing. But we see we go ahead and this does indeed pass. So cool. So it does indeed start in an open state. Awesome.